Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam, a former mimicker turned mather.
And I'm Kim, a reasoner who now knows how to share her thinking with others. At Math is Figure-Outable, we are on a mission to improve math teaching.
Because y'all, algorithms are amazing historic achievements, but they are not good teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. You know, I really like how we say the relationship part in there.
Yeah.
Like that mathing is about relationships with students and mathematical relationships. I like that.
Feels know your content, know your kids.
It does, doesn't it? Yeah.
I have a review to share.
Oh, I love reviews. Yay.
I know.
Hey, I got to say, when I met Laura Bro, who's in our coaching group, our Journey coaching group, I met her in person not too long ago in California. She has been valiantly trying to leave us a review. And I guess the way that, Google or YouTube or somebody messed around with podcasts, it's much harder to leave a review. So y'all, we get it. We sure appreciate it when you put forth the effort because it helps other people find the podcast. So thank you, those of you that are able to put in the time and effort to give a review. It means a ton. We know that it's not trivial.
Yeah. This one is from Math in Charleston, South Carolina.
Oh, nice.
And they say,
Somebody. You can do it.
Best math podcast for teachers of all levels. And when I saw that, I was like, ooh, all levels, like some are numerate and some are not yet, or grade levels. So anyway, he says, math, God, this is going to be a fun episode, Pam.
Hey, Kim, how's it going?
I cannot read today. Oh, holy no.
We can do it.
This person said, Pam and Kim bring humor and realistic ideas to all math levels. I always take away a new idea and solidify existing math learning. I'm a veteran teacher, but new to math. I taught ELA for years and needed a change. Teaching math and science, for me, is that change. I was never, quote, good at math. And with time, Pam and Kim have given me the confidence to be able to let the numbers dictate how I solve problems. My own number sense has increased with this podcast, and I'm able to help kiddos at all levels. This is the podcast that all math teachers need to listen to.
Oh,
thank you.
I love
that.
So sweet. I love it. You can tell that Math in Charleston SC has actually listened when I am assuming because this person says to let the numbers dictate how I solve the problems.
Yeah.
Like, that's a Kim quote right there.
Welcome to the good side of math.
I love it. All right, cool. Well, thanks for sharing that, Kim.
All right, Pamela.
Let's dive in.
Yeah, we are a few episodes in to our conversation about sequencing. And sequencing is so important to actually affect change. And, we do love changing up the types of lessons for so many reasons because you can do different things with different types of lessons. But hey, I want to let you know that we have heard about textbooks and district-made curriculum where it is, I do a sequence, friends, but it is the sameness all the time. Or it is, we do this strategy one day, turn the page, there's another strategy the next day, turn the page, another strategy the next day. And what we're talking about here is not that. We're not talking about turning the page and starting a whole new thing. What we're talking about here is landing for a bit to really develop connections and weaving things kind of all throughout to keep cycling back because we know that's actually how kids develop is to just lob something out, work with it, come back around to it.
Have a running thread. Sorry.
Yeah. No, go ahead.
Running thread of big major ideas, models, and strategies that we need to have kids keep developing.
Yeah.
And we do that by altering and sequencing different kinds of tasks and also, like you said, weaving in and out of like, let's start developing the strategy. Let's do some work with it with different types of tasks. Let's start developing another strategy. Let's come back and work on that first strategy. We're not going to pretend that kids can rote memorize a strategy in a day and that's worth anything.
Yeah.
It's not about having a set of strategies to solve problems. It's about developing the mathematical relationships that make those strategies natural outcomes.
Yeah. So if we were making a list of foundational things for multi-digit addition subtraction, Here would be some of the things on our list. We think it's important to think about friendly numbers, not just I like 12, so it's friendly, but important landmark numbers
I
that
like
are.
12.
I don't know why I said 12. I actually like 14 better. That's weird that I said 12.
That's
12,
funny.
12's richer, but I like 14.
You do
Anyway,
like 14.
so friendly numbers that are landmark important numbers to our place value system. We also think developing understandings about place value, not place labeling, is super essential.
Mm-hmm.
Doubles are important. The idea, like we talked about with single digit, the idea of adjusting, so adding, subtracting, and then adjusting a little bit is
So
crucial.
that's where your friendly numbers come in, right?
Yeah.
Like
Yep.
add a friendly number, so then you adjust, either keep
Uh-huh.
adding to add the rest of it or adjust back because you added too much.
Yep.
Same with subtraction, subtract a friendly number and then keep going if you haven't subtracted enough, or if you've subtracted too much, then you have to adjust by giving a little bit back, like sort of
Mm-hmm.
compensating. All of
Yep.
those adjustments are based on that very first thing you said, those friendly numbers and place value
Yep.
relationships.
Yep.
Yeah, nice.
We also will continue to develop the commutative property.
Mm-hmm.
Just properties in general are foundational. We also want to develop the idea of partial sums by splitting numbers. So decomposing, not just any random way, but in important place value ways.
Mm-hmm.
So these are foundational. And I want to just comment that these are add-ons to the foundational things that we talked about in single addition.
Well, actually, can I tweak
I
that a
just
little
said
bit?
single addition. I'm struggling today.
You're doing
Single
great.
digit addition.
So let me say that in another way. We mentioned some foundational common running threads, major relationships that we want to build in single digit addition and subtraction.
Yeah.
And really, they just grow up to become
Mhm.
the ones that we just mentioned.
Yeah.
So when you said add on, I'm actually going to request that we take that, like, we're not adding on. We're
Not plus.
It's
Not plus.
it's not additional to, it's not, now you've got to more. Now we're just going to grow up. Like the
Yeah.
relationships
Yep.
mature, they get a
Mhm.
bit more complex, more sophisticated.
Yeah.
And that's good news. If we develop those relationships when we're helping kids own their single digit addition and subtraction
Mhm.
facts, then bam, we just continue to develop them.
Yeah.
If, on the other hand, we're in kind of a traditional place where we're like, okay, kids, rote memorize these single digit addition subtraction facts, we now don't have those relationships to continue to build and develop to mature. We have to start from scratch because all they have is a bunch of rote memorized stories,
Mhm.
or like pictures in their head. We don't want just a picture of, I don't know, Mrs. Weeks sat on a chair eating two boots.
No, stop. No.
Okay, but we don't those.
Yes.
If I just have facts with a rap or a rhyme or a story, we haven't built in a kid, we haven't developed those important things that can now grow up into, like you just said, friendly numbers, place value, doubles, adjusting, the properties, partial sums, all of that we could have started to develop and now can grow up.
Yeah, thank you for that. That's a really good point, because as our kids are getting older, they're able to handle more complex numbers, but the relationships are the relationships. And we want to continue to develop in them how to trust the relationships that they've started to develop. When we develop these foundational things, and when kids are really grappling and then solidifying and analyzing and practicing, you're not going to be the teacher that says, well, I did this one thing, but they don't know how to do anything with it. Like, I did this one activity. We hear that sometimes from people, like, hey, I did something.
I taught them the strategies.
Yeah. But they don't use it anywhere, or they aren't applying it outside of this one task. And that's not surprising, because kids need to be immersed in opportunities to see these relationships happening, so that then these strategies become natural outcomes.
Mm-hmm. Yeah, immerse is a good word, and that's kind of what we mean when we say come back to, and cycle back and come around and have a running thread through your tasks, because those running threads can be super, super helpful, because the kid goes, oh, like we did work on that strategy last week a few times, and I'm seeing numbers today that are kind of begging for those relationships.
Yeah.
And if some of the students don't notice that, then it can be the teacher to say, sure wish I knew something about quarters, or sure wish I knew something about, like, whatever it is that we're sure wish I could add a bit too much here.
Mm-hmm.
Or, like say we're adding 39. Sure wish I knew what plus 40 was.
Mm-hmm.
Some kind of a drop to go, and the kid could go, oh yeah, like we did work on that last week. I could use that relationship.
Mm-hmm.
It's not me saying remove a friendly number and adjust. It's me saying, sure wish I could subtract 40 here.
It's a scaffold.
Yeah, and it's just enough in that moment, but it's an important scaffold that says we've been working on these relationships. Let's see if I can ping that if it's within the zone of your proximal development. If you can see my hands, I'm like creating this oval in the air here. If this is your zone of proximal development, can I throw something out that just hits the edge of it so you can grapple with it and use it and bring it in? Mm-hmm. All right. So Kim, what are some sequences of tasks? What kinds of tasks and what are sequences of tasks that we could do to help build the foundations for multi-digit addition and subtraction?
Yeah.
Important. So in the last couple episodes, we've talked about single digit addition, subtraction, and single digit multiplication, division. Today, let's grow up a little bit. I'm not saying that Henri, but let's get a little more complex and talk about multi-digit.
Sure.
And remember that we've talked about messier kinds of tasks that are not unstructured. They're not where kids are uncomfortable. It's not about sending kids off to discover math on their own. Kids are completely clear on what they're supposed to be doing. They know the goal. They know what how their role and how they're supposed to use the materials that are given to them. What they don't know is you haven't given them steps to mimic. You've given them a problem to solve, and they're clear on the problem, and they're clear on how to sort of go about that. We also have a couple of other types of tasks that we're going to talk about, and how do you sequence types of tasks like that. So, Kim, here's one of maybe, should I say my favorite? I think I could say my favorite. No. Favorite task to do with kids who are just beginning to really build the open number line. Mm-hmm. Which is not just okay, go do the open number line method. It's not that. Mm-hmm. It's not about a picture. It's like making kids draw pictures. It really is about creating mental maps that mathematicians actually have mental maps in their heads with which they use to see relationships, to feel relationships, mm-hmm. and then they use those relationships to solve problems. So we want to create literally open number lines in kids' heads. A way to do that is to have kids measure. So we can have kids measure, and one of the tasks that we've done is we've said, hey, if we want to create these shelves in our classrooms, and we're going to put books on the shelves, and the books are going to be, we're not putting them like in a normal bookshelf where the ends are sticking out. We're putting them, how do I say this? Side by side, mm-hmm. like width to width. Mm-hmm. Is there another way to say that? Like you can see the front cover. You can see the front cover, and then it's right next to the front cover of the next book. Yep. And we're kind of lining them up that way. And if we want to line up so we can see the front covers, and they're lined up right next to each other, perpendicular, parallel, parallel.
Front cover to front cover.
Front cover to front cover. And they're lined up on the shelf like that. Then how long of a shelf do we need for this particular book? Mm-hmm. What if we wanted 2 books lined up? How long? If it were 3 books, then how long would we need these shelves? Could we have kids take, I don't know, cubes? We got lots of cubes in the class. We could take kids, they have linking cubes. They could link them together, and they could measure certain books. And then we could say, hey, if we're going to put these 3 books together, how long does the shelf need to be? Or these 2 books together, how long does the shelf need to be? Mm-hmm. And then we could say, well, let's like sort of represent where those lengths are. And we could put cubes in a line, and we could do alternating colors of cubes. And listeners, if you're, let me give credit so I don't forget. I want to give credit to the inspiration for this idea to Kathy Fosno, mm-hmm. In her Measuring for the Art Show task in her, what is her Context for Learning? Yeah. In her Context for Learning program. She's got this.
It's on New Perspectives Online.
Thank you.
Currently.
Thank you. Uh-huh. New Perspectives Online. In there, she has this fantastic task, and we've tweaked it, made our own context, but it was based on that. So, Kathy, we really appreciate that inspiration.
Yeah, sure.
Could we then look at an alternating set of cubes where we've got sort of 5 one color, 5 of another color, 5 of the first color, 5 of the second color, and maybe we've got 100 of them kind of lined up. And then could we say, hey, where is a book that measures, I don't know, 13 cubes long? Where would that be? And then mm-hmm. ask kids, if they're looking at these cubes, where is the edge of that 13th cube? And how are they using those fives? And are they putting the fives together to make tens? And where would I put a book that is 31 cubes long? And how are they thinking about that? And kids might count by fives. Kids might put fives together and count by tens. Kids might use that we've already marked the 13, which helped us mark a 10. And they might just go from that 10 to the 30. So different uses of relationships. Then we could start to use that sort of those measurements that we've marked on that cube line. And we could say, well, what if I've got a book that's 31 long and I've got a book that's 15 long? How long does the shelf need to be? And we could go to where we'd mark the 31 and then we could say, hey, now we have to go 15 more cubes. How are we going to do that? Well, do we know where 31 and now we let kids sort of decide, do they want to go 31 and 10 cubes? Well, now we're at 41. We still have to go 5 more cubes. Okay, where's that going to be? Or could they, from that 31, could they talk about, well, I could get up to 40. I know that's 9, but I was supposed to do 15. So I've got to do 6 more. What is 40 and 6? And where would that be? And again, I'm sort of using that. If I'm at 40, I've got that 5 cubes after it flashing at me, because then the color changes, right? For the next set of 5. And so I can use that 5 and 1 more to just get that extra 6 and then kind of mark it. And lo and behold, I'm starting to add numbers using an open number line. Well, in that case, it's a bit of a closed, it's kind of a mix close open, because I can see all the cubes. But we're marking jumps above that cube line, and we can literally help kids start creating a mental map of being able to use 5s to get 10s and 10s to get other friendly numbers. We just mentioned it. What are some important things to do? Build place value, build that sense of friendly numbers, build this mental map of how numbers relate to each other. So we really like kind of a measurement task to get kids into the measurement model of an open number line, all heading towards adding and subtracting multi-digit numbers. Okay, so one of the kinds of tasks that we've talked about is messy. Let me give you another messy. So that one's kind of messy because kids are out measuring and then we're putting them together. What if we took I have, you need, and we did some more with it? So listeners, if you have not heard of the super cool instructional routine that Kim made up called I have, you need, then go check out one of the other podcast episodes. But briefly, we choose a partner. I'm going to choose, or a total. We're going to choose a total of 100 right now. So Kim, if I have 70, you need
30
to make 100. Yeah. So if I have 70, you need 30 to make 100. That's I have, you need. If I can make it more difficult, etc. Where it helps kids really travel the mental path of figuring the partner a lot, so that path of figuring the partner to the really important number 100, they figure that. So if I say I have 67, Kim, what do you need? I have 67, you need
33.
33. We want kids to travel the path of figuring that partner, so that path becomes a well-traveled path, and that they recognize partners of 100, partners of 1,000, partners of 10. That's the routine in a snap. If you want lots more detail on it, listen to another episode. But we can take that routine now and we can use it to connect addition and subtraction. So Kim, when I said, 33 is probably not a great partner. Let me do another one. How about if I have 78? No, 77.
Yeah.
There we go.
So you're going to have the same problem.
Am I tired today or what?
You are.
Okay. 77, you need
23.
23. Okay. So we're going to use 77 and 23. I'm going to take out my trusty pen so I can write these numbers down and make sure that I'm actually thinking. What did I say? 77?
77 and 23.
No, I don't want 77 because then I've got 2 sevens. Then I could have a 67. No, I don't like that either. 57. I like 57. Kim, if I have 57, what do you need to get 100?
43. You should maybe say why are all these rejecting? It's because they then have a partner that has 2 of the same digits. You've got some confounding numbers.
I don't want confounding numbers. If I say 3, I don't want them to look at the 30 or the 3 and not sure which number I'm referring to. So yeah, I'm going to choose 57 and 43. It's 4 different digits that we're dealing with.
Yes.
Thank you for letting me do that. Oh, preparation is not. Okay, so if I say, Kim, I have 57, what do you need? It's in effect, I'm asking the question, 57 plus blank equals 100. Would you agree?
Yep.
So we could call that a missing add-in problem.
Yep.
But I could also say, how is that related to 100 minus 57?
Yeah.
And now it becomes a subtraction problem. And we could think of that, the very same question, both ways. And using an open number line to represent what's happening, we can see that. So that 57 plus blank equals 100. If I had an open number line from 0 to 100 and I put 57, where would it be, Kim, about?
I'm sorry, I was writing on my paper.
That's okay. I have an open number line for, hey, we're a hot mess today. If the open number line goes from 0 to 100, and I'm going to put 57 on the number line, give me, where am I drawing?
To the right of halfway.
All right, so almost halfway is 50, or halfway is 50, so a little bit to the right would be 57.
Yeah.
Then I'm going to draw a jump from 57 to 100 and put a question mark above it. That's what we're asking for, right?
Yep.
Well, notice how that picture, so let me just draw it again. I've got 0 to 100, open number line.
Yep.
57 just past half, and then I've got a jump to 100. So I've got this arc from 57 to 100, and above it I have a question mark. So 57 plus what is 100? But it could also be 100 minus what is 57.
Yep.
It could also be 100 minus 57 is what? Lots of nice relationships that are far more than me just saying turnaround fact. And it's far more than me just saying addition's related to subtraction. Like, we're actually feeling the relationship. Yep. And so we could do some work with I have, you need to connect addition and subtraction. All right. Yep. Those are a bit messier. Another category of tasks that we like to sequence with messy tasks are tasks where we analyze strategies. We like to sequence those with problem strings where we really cinch and get better at strategies. So let's talk about a couple of analyzing strategy types of tasks. So one of them could be where we pick curated numbers. What do I mean by that? Well, I mean that we could actually choose numbers to give kids problems to solve where we've thought about the numbers and we're giving kids those numbers in such a way that we say, hey, how did you use them? So for example, I might say the number's 38 plus 2 plus 15. And I might say, hey, Kim, which numbers do you want to add first?
Yeah, I'm going to do the 38 and 2.
And then we'll sort of, hey, why? Ooh, that got us to that nice 40. Now we're at that friendly 40. And then, it's not too bad to add the 15. But I also might give you numbers like 38 plus 15 plus 20. And I might say, well, according to what you just did, you should add the first two numbers, right? And you might be like, ew, icky. Like, what, like 38 plus 15 plus 20, what are you going to do?
I'm going to do 38 and 20.
Bam. And then add the 15. So, there might be times where you add a friendly number and then tack on the rest.
Yep.
So in the first one, 38 plus 2, you got to a friendly number and then you added the rest. 38 plus 20, you added a friendly number and then you add on the rest. We can give kids numbers like that. Let me give you one more, Kim. What if we had 38 plus 15 plus 39?
I'm writing down 38 plus 15 plus 39.
Yeah.
Oh, can I double 38?
Yes, but it's not what I was going for.
Oh, okay. What are you do? So I'd probably do 38 and 40.
There you go. That's what I was going for. Yeah.
Yeah.
So 38 and 40 instead of 38 and 39. And then you back off one. And then now you'd probably tack on the rest of it.
Yeah.
So now we're having a conversation about adding a bit too much and adjusting back.
Yeah. Hey, I'm gonna jump in here for a second because this is an example of helping kids become judicious strategy pickers. So if you've developed some strategies with your kids, it is perfectly okay to lob out specific numbers that encourages them, that nudges them, that like you're like laying the groundwork for them to make choices.
It's like we're flashing patterns in front of them.
Yes.
We're high dosing patterns.
Yes.
And saying, notice this pattern.
It's the scaffold again.
Yeah. And we're very purposeful about it.
Yeah.
I can't tell you the number of times I've had conversations lately where people say, Pam, what you're suggesting is terrible. They say, when you suggest that we don't teach towards algorithms, you're suggesting that we just let kids loose and we're going to be mean and not tell them how to do math. And we're going to expect them to go out in a field by themselves and discover the algorithm. And I say, not what we're suggesting at all. We're actually very purposeful and focusing kids by flashing, high dosing these patterns at them. It's just what we're high dosing at them are the major patterns. It's the major relationships that lead to the major strategies that mathy people actually use. We're just helping them actually math the way mathy people actually math. Yeah, nice. I'm glad you brought that up. So one thing we could do is use curated numbers to have kids realize what they're doing kind of naturally. But we're picking the numbers on purpose so that they kind of do those things. And then we can point out what they did and go, let's put some words to that.
Well, I'm gonna interrupt you one more time,
okay.
because we in these sequences, we choose numbers to strengthen the muscle of looking at numbers, because then the natural outcome is that they tend to want to look at numbers. They're not going to always have the perfect numbers for the rest of their life. They're going to look for the relationships that they have developed and have gotten stronger in.
Nice. Yeah. So one other thing I want to mention is we've talked in the last couple episodes about smudge problems.
Yeah.
Where basically we put kids' work down, we smudge out part of the work, and then we have kids fill that in and then analyze what the kid was doing on the model that they just filled in. One of the things that we could do specifically here, I just talked about using I have you need to connect addition and subtraction. But in those smudge problems, we can also have kids notice that kids could answer a subtraction problem by finding the difference between numbers. We can put it in front of them. We can say, Kim was solving the subtraction problem, 78 minus 39, and fill in the smudges. And when they look, the kid looks at the number line, it starts at 39 on the left and goes up to 78 on the right. And then we've got some jumps in between, and they have to fill in the sort of, we smudged out where they jumped and we smudged out where they landed. And so the kid fills that in. And then we're like, wait, the problem was 78 minus 39. Why is 39 on the number line? So we can actually put in front of them that the kid was solving a subtraction problem using distance, using the difference between the numbers. And then right underneath that, we can have a kid removing the 39 and landing on the answer, again, filling in the smudges and then analyzing that. The big idea is that we're analyzing strategies and going, why would a kid do that? That's interesting. Want to work on that? Let's do a problem string to get that strategy actually pretty good. So we sort of put it in front of kids, high dose, flash them these patterns, and then do problem strings to help them get better at it.
Yeah.
As they get better at those strategies, then we can make anchor charts that sort of solidify those strategies. Now we have a few of the major strategies on an anchor chart, and then we can not only clarify the meanings by having the kids co-create those anchor charts with us. Now kids can reference those anchor charts when they're in their work. They're doing stuff and we can go, sure wish I had some strategies I could think about to solve that problem. Kids could look at the anchor chart and they could be like, oh, that's right. I have those relationships I could use. All right, so cool. We've talked about some messier problems we could do. We've talked about some analyzing strategy problems we could do. How do we practice the multi-digit addition and subtraction? Well, let me give you one way. I'm not going to say this is the only way, but here's a way that we kind of like. Could I put some smudge problems on a card for, I'm going to pick a problem, a specific problem. Maybe, I'm not even going to tell you what the problem is, but let's pick an addition problem. So say it's a two-digit plus two-digit addition problem. Could I solve that addition problem using one strategy on an open number line? Smudge out some of the work. Now I'm going to, on a different card, put that same exact problem with the same model on an open number line, but I'm going to put a different strategy. Smudge out some of the work. Could I have a third card, same model, but with a different strategy, same problem? So basically, now I've got the major strategies on the same model. Now I'm going to do the same thing with the major strategies on a different model.
Yeah.
Give those to kids and let the kids fill in the smudges. Then what do they have in common? I'm going to let kids look at those cards and say, find the same strategy, find the same model, and let them actually sort and get just more clarity around the different strategies and the different models, what the different strategies can look like on the different models, while they're practicing the strategies by filling in those smudges and analyzing those strategies. And then we could give them a new problem and let them go at that new problem, different models, different strategies, sorting all that out, making sense of it. That would be a way that kids can sort of practice those strategies. Often, Kim, teachers will say, I've taught them the strategies and they just still do an algorithm, or they still are splitting, doing partial sums, or they're still typing in their calculator, whatever. They won't use the strategies for whatever reason. Well, this is a way. Well, let me say one more thing. I try to force them to use the strategies, and Pam, they won't do it. So here's a way to not force, that's not a polite word or a polite thing to do, but to kind of insist that kids are diving into the strategies because
And
their task right now is to fill in the smudges and analyze what they're seeing. That's the task.
Yeah, it's intriguing. It's not what's the answer. It's
exactly
what's going on here.
Yeah. If it's just getting the answer, kids will just get the answer any way they want. But if it's analyzing the strategies by filling in smudges and then looking at it, now I'm intrigued. Now it's a puzzle to solve. Yeah, thanks. Go ahead.
What I like about this particular practice as well is as they're doing this intriguing work, kids are developing a better sense of the idea of strategies and models. And so it's working on the idea that you have kids say, I did a number line. because laid out in front of you for one problem are all of these different strategies and different models. I also recently spoke to a leader on a campus who said, how do you know when you see a problem, which model or which strategy you want to use? And so we got to have a conversation about the type of problem and the strategies. And I feel like the sense was that sometimes you do these models. Yeah. And sometimes you do these models.
And that we should know right off the bat which one's the best.
Right.
Yeah.
Yeah.
Well, and in reality, we need experience to say, ooh, based on these numbers, what strategy feels great and what model is flowing from me today. And if I own the models and own the strategies, then those choices become kind of natural.
Yeah.
That's nice. I like it. Y'all, you can create tasks like this and you can sequence them with problem strings to help your students build the major relationships that lead to the major strategies for addition and subtraction. If you'd like ready-made tasks that can help you do exactly this to build the foundations for strategies, check out our hand-to-mind product, Foundations for Strategies, Multi-Digit Addition and Subtraction, for easy-to-read lessons that can help you exactly do that. Y'all, thank you for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable.